Okay, hello and welcome to this video on energy calculations. Hey, since we're talking about calculations, why should you always trust your calculator? Well, because you can count on it. Okay, what's the purpose of this video? By the end of this lesson, you should be able to calculate an object's gravitational potential energy, given its mass and height, and to calculate a moving object's kinetic energy given its mass and velocity. So check it out. As a reminder, what is potential energy? It's energy stored as a result of an object's position. It's really just stored energy somehow. And the one kind of potential energy, there are several, but the one kind that we're going to focus on here is called gravitational potential energy. And that's the result of an object being above something else, being higher than something else. For example, these skiers are standing on top of a ski slope, so they have a lot of gravitational potential energy. They are stored a lot of energy that can be used to be turned into kinetic energy pretty easily. And the formula for gravitational potential energy is this. So PE for potential energy, little grav just means gravity. It's equal to mgh. M is the mass of the object. G is that acceleration due to gravity, which on Earth is 9.8 meters per second squared, and h is the height in meters. So we have mass in kilograms, g in meters per second squared, and h in meters. We're going to get potential energy in the units of joules. All right. If you need to, pause the video so you make sure you have this formula written down clearly where you can find it. So let's calculate an example. We've got a 75 kilogram skier, and that skier is standing 500 meters above the bottom of a ski slope, just like perhaps the people in the picture. How much potential energy does this skier have? So let me show you my Jamboard. We're calculating the potential energy, right? And so don't forget that potential energy is equal to m times g times h. And so what are these things? Well, we said that it was a 75 kilogram skier. We know that the g on Earth is 9.8 meters per second squared, and h is the height, and we said 500 meters. Right? Double check that I actually said 500 meters. Yeah. Okay, so now it's simply a matter of multiplication. As long as we have these units correct, as long as we have kilograms for the mass, meters per second squared in the g, of course, and then meters for the height, we can multiply. So PE is equal to 75 kilograms times 9.8 meters per second squared times 500 meters. And if we put all that into a calculator, get the calculator out for us. Here's calculator, 75 times 9.8 times 500. So that's 300, it's a big number, 367,500. And the unit for energy is joules. So that might seem funny because you already learned that the unit for work is joules, but since energy is just the ability to do work, it's also the same thing. So 367,500 joules is how much energy potential energy that skier has. Okay, now let's try calculating it a different way. So we've got an 80 kilogram skier. They have 15,000 joules of gravitational potential energy. We want to know how high they are. How high above the ground are they? So let's pull up our Jamboard again and try again with the same formula, PE equals mgh. Now we know that the PE is 15,000 joules. The mass is 80 kilograms, and the g is 9.8 meters per second squared. So what we need to do here is solve for h. So let's say 15,000 joules is equal to, I'm just substituting in here, 80 kilograms times 9.8 meters per second squared times h. So So to get h by itself, we're going to divide both sides by 80 times 9.8. 80 times 9.8. So that's going to cross those out, leave us with nothing but h here. So that's going to give us 15,000 divided by 80 times 9.8. Let's get our calculator back. So that's 15,000 divided by 80 times 9.8, close parentheses, is equal to, so they are, and here we're going to say h, up in my pen, h is equal to 19.1 meters, right, 19.1 meters. Okay. Now on to mechanical kinetic energy. So kinetic energy is energy of things that are in motion. It's energy being used, and mechanical refers to moving things specifically. And so that's related to the mass and the velocity of an object. So that here we have kinetic energy is equal to 1/2 times the mass of the object times the velocity squared. Times the velocity squared. There is an exponent in here, but we don't have to freak out. Still fairly straightforward math. And of course, the unit is still going to be joules. Energy is always in joules. So pause the video if you need to make sure that you are copying this formula down. Here's an example. I am shredding the gnar with a velocity of 20 meters per second. My mass is 85 kilograms. How much kinetic energy do I have? So, let's try this one out. Here's our formula. Kinetic energy is equal to 1/2 times mass times velocity squared. So we can substitute in 1/2 times the velocity, or the mass, my mass, I gave you as 85 kilograms. So that's times 85 kilograms. And what was the velocity? 20 meters per second, because I am so fast. So 20 meters per second, right? And 20 meters per second, and then we have to put that whole thing in squared, right? That whole thing in squared. So it works out to, our KE is 1/2 times 85 kilograms times 400 meters squared per second squared, which just sounds weird, but it works out to give us joules in the end. And so now we need a calculator. So half of 400 is 200. 200 times 85 for my calculator. 200 times 85 is 17,000. So 17,000 joules is our answer here. 17,000 joules of kinetic energy. Okay. Now let's see another example using the same kinetic energy formula. So I have 12,000 joules of kinetic energy as I ride my bike uphill, which means I'm really strong. What is my velocity if I and the bike have a combined mass of 100 kilograms? So let's try it again. Once again, I'm going to start by writing my formula down. So KE 1/2 mv squared. We actually want to know what the v is, so that's our unknown. Question mark for that. This is 100 kilograms, and this is 12,000 joules. So we can substitute in 12,000 joules equal to 1/2 times 100 kilograms times v squared. Simplify this to 50. And now we have 12,000 joules, and we're going to want to divide both sides by 50. So divide that by 50 kilograms. It gives us v squared, right? So then we can do 12,000 divided by 50. 12,000 divided by 50 is 240. So that tells us that v squared V squared is equal to 240 joules over kilograms. So V, now we have to take the square root. I'm going to change my color so it's obvious what I'm doing. We have to square root both sides. If we are going to get V simply by itself, we need to square root both sides. So that means V is equal to the square root of 240. And that's another great use of our calculator here. Let's just hit the square root button, and that is about 15.5, right? So that gives us a velocity of 15.5 meters per second. These units should work out so long as you have this mass in kilograms, this in meters per second, and this in joules. All right? So hope that was helpful. Those are some calculations, how to do calculations using the potential energy and the kinetic energy formulas. And I will catch you in the next video.